Hey guys, all right, so we're on to 3.5. These are the trigonometric derivatives. So we're gonna have to dig up our memories of our trig identities and stuff like that. So let's go over that real quick. But before I do that, let's take note of what the homework is. It is gonna be from the book today for this lesson, page 146, numbers 1 through 10. Okay. All right, so there are some things from trig that we have to recall. Let me zoom in on that a little bit for you guys. And let me tilt this. My left-handedness makes me go at an angle. All right, so from trig, there are some basic things that we learned, such as when we have sine x over cosine x, that's going to equal tangent of x. And we also have to remember our reciprocals. Ray, knock off this itching. She's having allergies so bad right now, and all she does is just itch herself. We've checked her fur, we've given her baths, there's nothing there, but she's like going crazy. Are your dogs going crazy too? Are they having allergies? Like, it's weird. She never used to have them. All right, so sine of x is reciprocal of cosecant of x. Cosine, do you guys remember, is reciprocal of secant. And tangent is reciprocal of cotangent. Oops, of x, not s. Okay. So there was a trig identity that we learned back in Enhanced Math 3. It was the sine squared of x plus the cosine squared of x. Do you guys remember what it equals? A big fat 1. And from that, when we rearrange things and divide everything by sine or divide everything by cosine squared, we would get two other identities that help us out. One of them was 1 plus cotangent squared of x equals cosecant squared of x. That was one of them that we derived from the Big Kahuna. The other one that we derived from the Big Kahuna, I'll put it over here, was tangent squared of x plus 1 equals secant squared of x. And then the last identity that we learned at the end of Math 3 last year was the double angle identity. Sine of 2x equals 2 sine x cosine x. So all of these things we're going to need to remember and recall and reduce, reuse, recycle for calculus right now. So it's not really anything new. The only thing new is taking derivatives of these trig functions. Okay, so let's take a look over to the left here. There are some derivatives of trig functions that we just need to remember. We already know the first two right here. We know these. We've already used them a couple of times. We've already seen on the graph like their limits and stuff like that. So we know that the derivative of sine is cosine. And on the flip side, the derivative of cosine is negative sine. So that information we knew. We already knew that going in. So we're a little bit ahead of the game. The new stuff is the derivative of tangent of x equals secant squared x. The derivative of cosecant of x equals negative cosecant x cotangent x. The derivative of secant of x equals secant x tangent x. And the derivative of cotangent of x equals negative cosecant squared of x. Okay? Notice something. The derivatives of words that start with C are negative. So the derivative of cosine is a negative sign. The derivative of cosecant has a negative out front, negative cosecant cotangent. And the derivative of cotangent is negative cosecant squared. So it's kind of a helpful way, a little pattern there to help us remember these. What I recommend, especially as we're practicing using these, you don't want to have to refer back to this all the time or dig it out. So I have my nifty little index card. So I've written down like the limit as x approaches 0, sine x over x. This is one of the first things that we needed to remember when we were learning limits, like a couple months ago. Here's a double angle identity. I always forget this one, so I wrote it down. And I decided to write down all of the trig definitions that we learned last semester, because they're good to, or not last semester, last school year. So they're good to know. Like, these are the ones we learned in Math 3. And then I wrote down the derivative ones. Now this one I remember because it's easy. That I always forget about the negative, so I have to make sure I have these down. It helps when you write them down. So then I have them all in this nice little index card thingy, and I can go back to it and just have it next to me whenever I need it. And it's cute. I got it at Target. I like it. I got it because of that, because it's got a pug. Anyways, it comes in handy when you do stuff like that. Nice little study habit. Okay, so we're not going to do example 1. We're not going to prove why the derivative of sine is cosine. We've already kind of gone through that anyway, so no need to do it again. But example 2 says to prove that the derivative of cosecant equals negative cosecant cotangent of x. Okay, so let's do this one though. Well, cosecant, we know, is the reciprocal of sine. So cosecant is the same as 1 over sine. So I could rewrite this as d dx of, 1 over sine x. Okay, and we're going to verify when we do this derivative that we should be getting negative cosecant x cotangent x. So let's see that we do this. Well, I've got a fraction there. And what's nice about that fraction is now that I have something divided by something, I can use the quotient rule. We just learned that. So remember, it is low d high minus high d low over low squared. So the low is sine, so it would be sine x, times the derivative of the high, which the derivative of a constant is 0, minus high d low, so the high is a 1. The derivative of sine is cosine, all over low squared, so sine squared of x. Okay. Well, sine of x times 0, anything times 0 is 0, so that gets wiped out. So I have negative cosine of x over sine squared of x. Now, you should be thinking, hey, wait a minute, sine over cosine is tangent. Well, what's cosine over sine? You guys remember? Cotangent. So I can get the cotangent that I need from this, but I need to split it. I only need a sine x in the denominator. I don't need a sine squared x. So what we're going to do is we're going to split that apart. So I'm going to, for our notes, put split so that you know what you're doing, or you know what's happening. So I can have negative cosine x, and I'm going to split that sine squared. So I'll put one of them over here, and then I'll split off the other one. So if I were to multiply those fractions across the numerators, across the denominators, I'm still going to get back to negative cosine x over sine squared. It's just now I have it split because now I know what this is. This is going to be, because it's negative, negative cotangent of x. And 1 over sine is the same as, well, sine's reciprocal is cosecant. So that would be the same as cosecant of x. And hey, look at that, negative cotangent x, cosecant x, negative cosecant x, cotangent x. When we're multiplying, order doesn't matter, so this is the same. Check. We proved it. Okay. Example 3, it says differentiate the following. So anytime we see the word differentiate, that means we've got to take a derivative. So we're going to take the derivative of this. All right, so let's try it out. So the derivative of y prime equals, well, the derivative of x is just a 1. Just remember that exponent is 1 and we drop it in the front. And then 1 minus 1 is 0. Anything to the 0 power is 1, so it's just 1. And minus the derivative of tangent of x. If you don't remember it, it's up here. Derivative of tangent is secant squared of x. So 1 minus secant squared of x. But this should look highly familiar, because we do have an identity tangent squared x plus 1 equals secant squared of x. So if I were to subtract 1 from both sides, then I can get the, or no, wait a minute. I need 1 minus secant squared. So I need to subtract the secant squared, so I could have 1 minus secant squared. And I'm going to need the tangent squared on the other side. So I'm just going to put this down here so we can show the work. Because sometimes when I say it out loud, you're like, oh, but when we do it, it makes more sense. So this is what I want to achieve, 1 minus secant squared x. And we're almost there. I just need the secant squared x on the other side because I need 1 minus it. Oops. Okay. And then I can't just have nothing on the right, so we got to move the tangent squared x and subtract that from both sides. So I will have 1 minus secant squared x equals negative tangent squared x. So now I can take this that I have down here, the 1 minus secant squared x, and since it's equal to negative tangent squared x, I can replace it with that. So that means that y prime equals negative tangent squared of x. And there's my derivative. You want to make it as simple as possible. That's how you know when you're done. If you can't switch out anything else to make it smaller, then you're done, pretty much. All right, letter B. We're going to differentiate y equals x secant x. So basically I have x times secant x, so that means I'm going to have to use the product rule on this bad boy right here because we have two things being multiplied, two quantities being multiplied. So let's get to it. So y prime equals, so the first is x times the derivative of the second. So the derivative of the second part, that would be the secant x. So if we don't remember, we can go back to our little chart here. The derivative of secant x equals secant x tangent x. Okay, plus now we need the derivative of the first. So derivative of the first, the derivative of x is a 1 times the second, which is just secant x. Okay, so now let's see, all I have is, if I take away those parentheses because I don't really need them, x secant x tangent x plus secant x. Well, they do have that common factor of secant x, but even if I factored it out, I would have x tangent x plus 1, and there's nothing I can replace that with. So I can't make this smaller, so it's done. And there's the derivative. I like these. They're actually not that bad. They look kind of scary just because they're trig functions, but they're really not that bad. You just got to know your trig functions, your identities. And as long as you know that or use your index cards to refer back to, you're going to be fine. Let us see. So it says y equals 1 minus cosine x over sine of x. And we need to differentiate it. Whoops, my notes are in the way. Okay, so let's differentiate it. Let me zoom in a little bit more. Okay. So I have a quantity divided by a quantity. So that means I'm going to be using the quotient rule to differentiate this. Okay. So remember, low d high minus high d low over low squared. So y prime is going to equal, well, the low is sine x times the derivative of the high, well, the derivative of 1 is 0, and then minus the derivative of cosine x is a negative sine x. So that's a double negative, so that's going to turn into just a sine x. So low d high minus high d low, so the high is 1 minus cosine x. The derivative of the low, the derivative of sine is cosine of x, all over low squared, so that would be sine squared of x. All right, and let's clean this up a bit. Let me zoom out a little bit more so you can see the whole thing. Okay, so 0 plus sine x is just sine x. Sine x times sine x is sine squared of x. minus, well, actually, let's multiply these first. So we have to distribute the cosine of x. So that would be 1 times cosine is cosine of x. Negative cosine x times cosine x is negative cosine squared of x. But remember, we're subtracting this, so we have to distribute this minus sign to both terms. So that would be a minus cosine x plus cosine squared of x all over sine squared of x. Okay, well, I see something. I see a sine squared and I see a cosine squared. And we know that sine squared plus cosine squared was one of the trig identities we learned last year. And we know that when we have sine squared x plus cosine squared x, that's going to equal 1. Okay, so adding up these together, that equals 1. So I'm going to bring this down over here, draw a little arrow. So I'm going to have 1 and then minus cosine x all over sine squared x. Okay, and I'm going to split this apart. I'm going to split apart that sine x because I see potentially cosine over sine at some point. And I want to be able to make it smaller. So I want to see how far I can go because you need to go as far as you can. So I'm going to split this up, 1 over sine squared x minus, because we're subtracting, cosine x over sine squared x. As long as they have the same denominator, that's allowed. We're going backwards. We're undoing the subtraction pretty much. Okay. And 1 over sine squared, well, we know that sine is the reciprocal of cosecant. So this is really cosecant squared of x. And then we can split apart the cosine x over sine squared of x next, just like we did on the first page for one of those examples. So let's see, I'm going to have cosecant squared of x minus cosine of x over sine of x times 1 over sine of x. Splitting apart the squared sine. And we know that cosine over sine is cotangent of x. So that's going to cut things down a little bit. Okay. So I'm going to have cosecant squared of x minus cotangent x. And we know 1 over sine is cosecant. So cosecant of x. And even if I were to factor out the cosecant, that would be 1 minus cotangent. If the cotangent were squared, then I could do something else, but I won't be able to simplify that any further. So that is the derivative. So I think the hard part with these is knowing when to be done with simplifying it. That's the hard part. We're going to skip letter D. Excuse me. And we're going to go on to example 4. It says find the tangent and normal lines for the graph. So finding a tangent and normal line, we've been doing this a lot. But now we're dealing with trig functions. But the process is still the same. Finding the slope of the tangent line means we need to take a derivative. And then when we find the slope of the normal line, we use the same stuff. It's just now we have to take the slope and find its opposite reciprocal. And then we have the normal line. Okay, so they gave us the x value, but we know we're going to need the y value. So let's go ahead and find that y value first. Okay, which means I have to plug in the x value into the function. So f of 2 equals tangent of 2 all over 2. Well, how are we going to do that, Mrs. Garcia? Well, you see there's this thing called a calculator we get to use for this problem. So tangent of 2 divided by 2 is negative 1.09, approximately. Okay, so now we have that out of the way. Let's go ahead and take our derivative. Because remember that we're taking a derivative so that we can find the slope. Okay, now for this one, because it's tangent of x divided by x, we have a quantity divided by a quantity. That means we're going to be using the quotient rule. So f prime of x is going to equal, well, remember it goes low d high minus high d low over low squared. So low is an x, so x. And then the derivative of tangent of x, if we don't remember what that is, derivative of tangent is secant squared of x. So we'll have secant squared of x minus high d low. Well, the high is tangent of x. And the derivative of the low, the derivative of x is a 1 all over low squared. So x squared. Okay. So now we won't be able to really clean that up any further, but we need to plug in a 2 anyway so that we can find the slope at this derivative formula. So that means now we need to plug in the 2. So f prime of 2 is going to equal 2 times secant of 2. That squared basically means you're squaring whatever that answer is, minus tangent. Tangent of x times 1 is just tangent of x, so tangent of 2 all over 2 squared. Okay. And we're going to have to use our calculators for this. And one of the things that I need to point out is that our calculator doesn't have a secant button. So we're going to have to be creative with how we type this into our calculator. We know secant is the reciprocal of cosine, and we have a cosine button on our calculator. So basically, we're going to have to type in 1 over the cosine of 2, but remember this is squared, so we're going to have to make sure that we square it. Okay, so let's figure out what that is first. So I need parentheses, 1 divided by cosine of 2, close parentheses, and then square it. I get 5.7743. Okay, keep that in your calculator and let's subtract the tangent of 2. So minus tangent of 2 and hit equals. Get 7.9594. Oh shoot, I messed up. I didn't multiply by the 2 out front. Let me start over. My bad, guys. Okay, so start with the, again, parentheses 1 over cosine of 2 squared. We had that part already, the 5.7743. But let's not forget, we need to multiply that by 2 first. There we go. And then minus tangent of 2 equals. And then divide by 2 squared. So divide by 4. So we approximately 3.43 to the nearest hundredth. So this is our slope. Yeah, it's a decimal, but that's totally okay. That happens sometimes. Okay, so let's write our tangent, our line equation. So t of x equals the slope, 3.43, times x minus the x value was at a 2, and the y value is at negative 1.09, so minus 1.09. And there's the equation of our tangent line. For the normal line, we need the opposite reciprocal of the slope. Well, the slope is 3.43, so the opposite of that would be negative 3.43, and the reciprocal would just be negative 1 over 3.43. No need to make it any harder than it is, right? So that's totally an acceptable way to present that answer. And then x minus 2 minus 1.09, using those same x and y value. Just remember, these two lines are perpendicular, so they're using the same x and y value. They just have different slopes. All right, so that part, the process is still the same. The difference is knowing how to take the derivative of a trig function. All right, example 5, find y double prime of y equals the secant of x. So to find y double prime, we first need to find y prime. So we're going to find the first derivative. Well, secant of x. What is the derivative of secant of x? Right here is secant x tangent x. And we would be done if we weren't asked to find a second derivative. But because we're asked to find a second derivative, we need to keep going. Now here I have a quantity times a quantity. So that means I'm going to have to use the product rule. on this portion. So y double prime equals, well, we need the first is secant x times the derivative of the second. So the derivative of tangent of x. Tangent derivative is secant squared. So times secant squared of x plus the derivative of the first. So the derivative of secant of x is secant tan of x times the second, which is tangent of x. Okay, let's clean this up a little bit more. So y double prime equals secant of x times secant squared of x is now a secant cubed of x plus secant tan times tangent is now secant of x tangent squared of x. And you can even write the tangent squared of x in front of the secant of x or vice versa. It doesn't matter. Because when you're multiplying, order does not matter. And that's as low as we can go. All right, so that was example 5, and that's it for this lesson. Go ahead and get started on those problems, numbers 1 through 10, page 146.